Depending on your time zone, good morning, good afternoon, or good evening. I'd like to welcome everyone to the Power of Ultimate Storage Solution webinar. This webinar is presented by AIC, OpenE, and Neurothink. My name is Joe Kimpler from AIC's Office of the CTO, and I'll be your moderator today. Before we start in the classroom, let me provide a quick overview of the webinar's format and some quick start tips. The webinar is broken down into 3 presentations: AIC, OpenE, and Neurothink. If you'd like to ask questions, please type them into the question box and they will be answered during the Q&A session at the end of each of the presentations. Lastly, all of the presentations will be available for download from the handout section of the GoToWebinar and will be posted to AICIPC.com for future reference. AIC is excited to host 3 high-powered speakers today. The first is AIC's Federico Papanini. He's a Senior Product Manager. The next will be Todd Maxwell, OpenE's VP of Technical Sales and Support. And the third will be Rick Rodriguez from Neurothink, the Infrastructure Lead. We'll start with AIC's Federico Papanini. Federico will provide a technical deep dive into AIC's NVMe shared storage platform. Federico, take it away.
Hi guys, my name is Federico Papayani. I'm one of the product manager here at AIC. I've been with AIC for quite a long time, over 10 years. Today I'm going to deep dive a little bit more on the Availability product line and our cooperation with OpenE. Todd, with that, I'll pass the ball to you.
Thanks, Federico. I'm Todd Maxwell, as Technical Sales and Support for OpenE for about over 15 years. OpenE was founded in 1998 by Christoph Frank, our CEO, who is currently our CEO today and will always be. OpenE's products have always been software-defined storage platforms. So in short, our software manages the storage, the servers, components in the system, everything from the CPU, the RAM, the NICs, drives, and other devices to present the most popular protocols used today for SMB and NFS and iSCSI. With that, we're going to be demonstrating the Jovian DSS, which is based on ZFS, the Zettabyte file system, which is what we'll be presenting with the AIC system today, and along with Rick Rodriguez as well. So I'd like to pass over to Rick Rodriguez from Neurothink. Rick, can you tell us a little about your company?
Sure, Todd. This is Rick Rodriguez, the Infrastructure Lead at Neurothink. Neurothink was established about a year ago now with the vision to make powerful and secure machine learning tools accessible to students, data scientists, companies with and without data science departments. Meaning if you're the command line type and you want to get deep into the modeling work, you can. But if you're not, we can guide you through the data importation process and modeling to get the results you need. That's really what Neurothink is all about. It's to help everybody get into machine learning, whether you're a professional or you're new to the process.
Rick, I know it's a special day for you, so why don't you go ahead and let us know what's special for you guys.
Thanks, Joe. Like Joe said, this is Rick Rodriguez from Neurothink. Today is the global unveiling of Neurothink as a brand and as an organization. My CEO, Brian Rogers, is in Dubai at a blockchain conference, currently unveiling the company publicly. And to kind of commemorate that and to do a basic introduction here, we have a video to play of my CEO, Brian Rogers.
Hello, everybody. This is Brian Rogers. I'm the CEO of Neurothink. Sorry, guys, I could not be with you for this conference today. I will be jumping on stage very soon here in Dubai to announce Neurothink to the world. So first off, I want to give some thanks to both AIC and OpenE. Great partners as we've been working with them. We've discovered some really amazing things about our infrastructure, quite remarkable results. And later in this webinar, you will hear from one of the individuals of my team, Rick Rodriguez, who will step you through all the details of these amazing results. So, and guys, I would love to get feedback and have you have a chance to look at our site. So for our site, neurothink.io. And if you want to send us a note, send a note to info@neurothink.io. Again, sorry guys, I couldn't make it with you today, but have a great conference.
Allow me to explain the reason for this webinar. The OpenE and AIC solution reduces downtime, allows maintenance windows, provides scalable growth, and maximizes performance while working within the constraint of your budgets. So Rick, why don't you give us a quick briefing into Neurothink's that's important and just not which storage.
Thanks, Joe. Neurothink, as a startup, we needed a platform that we could get into quickly, efficiently, and affordably, and software-defined storage fit that model very easily. We knew as a startup, we weren't going to go and buy a giant SAN array from, brand XYZ, and we bought a AIC unit with Jovian preloaded, with not a ton of experience in either platform, and got it all set up within a short order. Got it set up, and we currently have it feeding NFS to our VMware clusters. And from the seat of the pants feel, it's impressive. I could not tell the difference between local storage and network storage, which hasn't been my experience in the past. It's been very low latency, very efficient, and I look forward to really stressing it under a public data modeling load.
Thank you, Rick, very much. Federico, would you please go ahead and give us a briefing on the AIC storage solution?
All right. Today, what I'm going to do is introduce one of the latest Availability product from AIC. Availability means that it's a system that really cannot go down. The classical 5.9. The system needs to be up and running 99.999% of the time. So, which makes only a few minutes out of the year of offline. Specifically today, we're going to discuss about the HA202PV. What looks like is a system is a dual node at swappable based on our AIC design motherboard, the Pavo, which can support up to, in total in the system, 4 Intel Scalable Gen 2 CPUs. Up to 16 DIMM modules per system. And the most exciting part, 24 drive, dual loop NVMe in the front. What it makes the design so fittable for low latency, high performance. If we look at the CPUs, each of the 2 CPUs is connected to 12 NVMe drive in the front directly. So we allowed, very short latency and high performance, high bandwidth between those. If we look at the performance of the drive in the front, we would need to have a lot of bandwidth to extract the performance out of the box. So we'll look up a little bit later on how they look like. Something that is very special about AIC Cluster in a Box system is how we route everything that is necessary for the 2 nodes to connect internally. So which makes the design very clean on the outside. The deployment doesn't need external wiring between the 2 nodes for any RBit or link between the 2. If we look at the back of the unit, we'll see there is a lot of expansion slots. Other than the 2 10 gig ports and the 2 1 gig ports, we also have a bunch of extension cards. 2 x16, 1 regular PCI, 1 OCP, and x8 card for external connectivity. Also, each node has a dedicated port management for IPMI. So other than the NVMe, of course, AIC offers a variety of solutions in the HA market. So if necessary, or if the network requires less performance, we have a version that works on SAS and 2.5 inch, of course, native SAS. And also we have a 3.5 version in a 4U system. Let's see how actually OpenE can take advantage of this platform. Of course, if one of the other players don't have any question for me.
Federico, I got a couple questions on those dual port NVMe's. Are there anything special about it? I mean, could you purchase that off the shelf, or these special? I mean, is it 4 lane, 8 lane? How is that possible where typically, for us to see the drives for both systems, it needs to be SAS, so dual channel. So anything specific about the NVMe's that you're using to make that magic happen?
Actually, those drives need to be a little special. They are off the shelf. Many manufacturers, they have this kind of drive, starting from Samsung, Intel, Micron, so Netlist, and so on. Many of those drives actually are qualified with our system. The special sauce on those drives is the generally U.2 are 4 lanes total per drive. Those drive, what they do, they split the lanes in 2. So you're gonna have access from each node as the by 2 performance.
Okay, got it. And are there, like, we're going to be showing the 800 gig drives. Is there drives that are larger or not, or they're coming in the future?
There are drives available at the moment. We used to use the 800 as a benchmark, as an entry point benchmark. But yeah, there are availability on drive up to 30 terabyte actually. So and a lot of those different brands and different capacity are going to be certified in the system.
Got it. Just a couple more questions. Do you guys do custom builds? So let's say for fiber channel HBAs, and what vendors do you typically use if you do that? And also 100 gig E's.
So we're gonna have a couple of built just as off the shelf with minimum capacity and minimum, connectivity on the network. But yes, we can, working with different customers, we can customize the system to different workload, from the drive capacity side to the CPU's performance down to the network. The system itself comes already with 2 dual 10G and gigabit. But yes, it can be customized with additional fiber channel cards, SAS cards, or even if performance required, going up to 100 gig cards. The system actually we're gonna see today from Todd has 2 Mellanox cards, 100 gig cards, but we are compatible with Intel and also Broadcom cards.
I get this question a lot on the CPUs, on the silver Intel or those gold Intel CPUs, especially with high performance on the NICs, 100 gig E and components. How do you guys view that? And what do you do with standard shipping on that, or is that just a custom build?
So as I mentioned it before, we're gonna have a few CPUs. They're gonna be just as a mainstream. But depends on the workload, you can customize the CPUs. We generally don't recommend to go on the smaller side of CPU or less capable CPUs, because at the end, the bulk of the cost is still going to be on the drive side. You don't really want to waste the performance of the drive just using entry-level CPUs. So you can save a few $100 on the CPUs, but then you're wasting on ROI on the drive. So we recommend to go on a minimum of gold CPUs. Silver will work on specific platforms, but yeah, if you want to extract the performance of the drive and the I/O, yeah, you want to be on the gold side. And also, higher the clock, most likely you can extract better network performance from your cards.
Okay, that's all I needed. I'm going to go slide on to my presentation. So on the OpenE side, this is the AIC system, which is the high availability 202-PV HA all NVMe shared storage cluster. This is what we certified at OpenE. We do these certifications extensively. We just don't burn a protocol for a couple hours and call it a day. So it takes about 30 to 40 days. There's burn-in time, performance time, all different types of scenarios you can possibly imagine when we do our certifications. And on our website, you can see the certification where we demonstrate the performance, the time the failover events happen, and the specifics of the system itself. And of course, as you just heard from Federico, that we can make customizations and modifications to the system. You can add on 100 gig E cards, fiber channel HBAs, SAS external HBAs for extending your growth capacity. So in short, this image is just showing that you have two systems in one box. So essentially two servers, what we call in simplified terms, node A, node B, node A being an independent system. And then those drives are all connected to a backplane of such or an internal JBOD where we're able to see the NVMe drives to present the storage. So if you kind of like pull it apart, you could essentially see this as two different systems. And although you could do this with two different systems with SAS external HBAs to connect to just a bunch of drives, you can also use fiber channel as well. And that's one of the questions I was asking Federico, is that they do support fiber channel, because there is need out there for that high performance and payload from the fiber channel protocol. So that diagram kind of shows that. And then of course, this is not the system, but we do show that we do have other cluster features available to offer those functions. And here is just what's called a metro cluster. So AIC does provide other servers that you can do if you're at greater distance than just from building to building, let's say. So up to about 50 kilometers, and you need to do this via Ethernet, and you want to replicate your data. So you have data redundancy. The product that we're talking about is the Jovian DSS, which OpenE has had in the market since 2015. And OpenE is a software-defined storage company, and our platform serves for large and medium enterprises. So we are ZFS-based out of a file system. We're on an OS, a Linux OS, Debian, for a storage server. We're hardware independent. We support iSCSI, NFS, Samba, SIPs, and also fiber channel, which is listed on the other page. We provide the high availability. We give the tiered RAM, the SSD caching, thin, thick provisioning, inline data duplication and compression, self-healing capabilities, and we scale really into the petabyte ranges. We also offer the on and off-site data protection, which is a big feature. I mean, my God, you heard of Kia, which was hacked, and recently Colonial Pipeline was shut down in the Southeast. In this feature here, it comes free with the product. So if they would have had that, they wouldn't have to pay those $1 million to the arsonist or the hackers to be able to get their data back in production, back online. So with this feature is a real nice feature that we see a lot to take into the industry, and our customers really like that, to have that data redundancy and that ability to be able to bring that data back that was 1 minute ago from a snapshot, and they don't have to worry about hackers. So before we start going into the GUI and just peruse a little bit of it and demonstrate it, I did want to bring up that this is the certification for all the products and servers from our vendors and resellers. Right here, if you go to find certified servers and you click here, and you'll see listed in hundreds of different systems. You'll see AIC, the one that was done in April of this year. And we were talking with Federico about the silver or gold processors. Federico, here is, I wanted to bring this was the detailed information of the CPU that we certify with one of your many systems. Also listing the type of RAM, the information about the Samsung. And of course, if you click here to download the PDF, we have a deep dive detail report of the performance of the system, type of failovers we've done with the system, and how it passed our certification tests. So I just wanted to bring that up for everybody's attention. That's right on our website.
Okay, got it. Thank you.
Okay. So here we are. This is the GUI. We're using a browser. I like to preferably use the Firefox, although you can use IE, Chrome. But in essence, we've already set up the system to get this webinar to flow a little bit easier. Basically, I have two systems, Node A, Node B, that are listed here. We are on the AIC system. If we go to the system settings, I like to show the components and then the components making the failover. And here we have the NICs that are available, the Intel NICs that the AI system provides. It comes standard with the 2 onboard 1 gig E's, and those 10 gig E's, those X722s, Federico, those are on board as well, or those are add-on cards? So you got the 2 1 gig E, you got your IPMI NIC, which is a 1 gig E, and then you got your 2 10 gig E that's in the system. That comes standard in the system, right?
Those are actually standard on the motherboard, correct?
Got it. Okay. So in node B, though, we're showing that we have, let me go there right now, system settings, that we show the other 2, which have the 100 gig E that we're going to show in a second. So here, if everybody looks on E4 and 5, those are the Mullinox, those are the 100 gig E that are the add-ons. So that's what this box is showing, that we can add for 100 gig E purposes. Rick Rodriguez, do you have the 100 gig E in your system?
Yes, sir. The Mellanoxes, I have one of the Mellanox, the 2027 800s. Yep, same ones.
Now, how are you using that before I go forward? Because we probably will switch to your screen, but you're using that just for obviously for the NFS storage, right?
Yes, so we're using one of the 1 gigs for management, and then we're using the 100 gig port to do all of the actual data transfer, bulk data for all the VMware clusters.
Got it. Okay. So really in our setup, we recommend, and we have a how-to guide that if anyone wants to reference, if you just go to our downloads, how-to resources, we have a step-by-step guide that walks you through how the design should look. There are different designs. We have some notes, and then we walk you through the step-by-step guide. Even Rick Rodriguez from Neurothink went through this guide, and he was able to set up the system. It's real simple. Let's move forward, though, we can always refer back to that. If we have the bond, which is one of the main things that's recommended, we need an active backup bond. Creating a bond interface is really simple, everybody. You're selecting the NICs that you want to bond. Of course, I'm simulating this. You select the type of bond. Of course, in our failover in high availability, we need a bond. We want you to select an active backup. Select your primary interface 0. And then, of course, you can go all the way down to setting dynamic or static IP addresses and set that up. Make sure that when you do that, please assign the nodes to be for the server name and the host name, node A and node B. As you see, I have it noted here. So many networks and environments I see, they're just long letters and numbers mixing. I don't know where and what is at what. So it's important to node A and node B so I know which system. Once you have that set up, then it's really setting up the failover is really simple. Is here you're seeing that what I'm connecting to is the 2 bonds, and those are going to be my failover nodes, and they're also tied in. If you see to the GUI here, I'm using 17.50 in the 3rd and 4th octet. Is that node A and node P? What we're doing is we're creating a ring node between the 2 for failover nodes. Once you set that up and you connect, it's going to tell you, by the way, as I scroll too fast, it's going to say that it's reachable online. So set your bond, connect your nodes, it'll stay online and reachable. At this point, you want to set up what's called your ping nodes. Ping nodes are part of the pseudo cluster. So what is a good ping node? Well, something that has 99.99% uptime. Something's going to have a UPS or a generator, something that I know it's going to be up if there's a power outage. Well, typically, most of the engineers have a big UPS on their router, firewall, and switches, right? So that would be a good ping node. And another ping node would be an ESXi host, or I've seen even engineers put network interfaces or use the network interfaces on their UPSs. Although if the UPS runs out of power, well, then one of your ping nodes can go down. Once after you set that, by the way, I recommend usually 2 to 3 ping nodes in an HA, and in a metro cluster, 2 on site A and 2 on site B, so you have a balance there. So a total of 4 ping nodes. Once you have that set up, then it's real simple. Everybody, you just start the failover and it tells you started. Very simple. We do recommend also you can add another what's called a ring path. And so I can use another dedicated NIC that will be part of the ring path, that if my main ring here, as you see on my bond, and that doesn't have to be a bonded interface. So my secondary ring path can just be a single interface as long as they're talking to each other. That way, if this bond breaks for whatever rhyme and reason, physically or logically, you can continue on the other ring path. So that way they're telegraphing and sending information in microseconds how the failover heartbeat is. And using the ping nodes, hey, do you see ping node X? Yes, I do. So they keep working that way behind the scenes. You don't even know what's happening to keep that failover running. Once that's done, you're just going over to the storage. And at this point, you'll see that I'm seeing the local disk. Now, this is what Federico and I were talking about, is the dual port NVMe's. And here in this system, we round off the numbers to 800 gig for marketing reasons, but it comes out to 745 with the NVMe. And if you notice on node B, it's saying the same disk. We will go there right now. And you're seeing it also as being a local disk, and the same disk, the same serial number and model numbers as well. What we're going to do is create a quick, simple Zpool. We're just going to go to add Zpool. And here we're going to be able to select just a couple disks, just to give everybody an idea how simple it is. I'm going to do what's called a Z1, which is like a RAID 5. One disk is going to be used for parity. So here I'm selecting a Z1. I'm going to add it to the group. It's going to swing it over to the right. I'm going to go to next. Being that it's NVMe, you really don't need to have a write log. So I'm just going to skip that, although I've seen others have it because they want to use it. Here, we're just going to go ahead and create next and go to read cache. Maybe I probably want to use 1 for read cache because I think I have a customer who's going to be demanding a lot more reads than normal. So he's going to be reading probably 80% of his data. So we'll give him read cache. Go to next. And then, of course, any spare disk I want to add, I'll just add 1. Add that to the group. And if you notice, it's listing everything on the right as other groups, totaling up the capacity as well. And of course, your data groups. And I can expand those data groups later on. So for example, Rick may be in a position where he may want to grow Neurothink's capacity for their customers. He could do that. And he could do that without impeding any downtime. Now we're just renaming the pool name. I'm going to take the standard name, Zpool 0. And of course, now it's just going to format. It's going to carve out some for metadata, and it's compilation of the ZFS pool. And then it's going to present the ZFS pool. And you're ready to go ahead and create what's called the data set, or ZVal, for iSCSI and fiber channel. And also to be able to go ahead and add your virtual IP addresses. So here's your Zpool. You're able to see your disk groups. If a customer like Rick who wants to expand and add a group, he can. So add a group. He can always add a write log. You can always add a read cache. He can subtract a read cache and write log as well without impeding the system. So if we wanted to add another one, we can, and we just select. You want to definitely keep it in the same Zpool specific, so you want to make sure that you're not doing a Z2 with a Z1. you want to keep it the same. So Z1 to Z1, add group, and apply. And so now my capacity has grown on the fly and without any downtime impeding customers and so forth. Here I can just add an AIC target. It's real simple. Or you do NFS, just generate the name, the Zpool. This is the storage. We'll just call it Zval-00, and we're going to select maybe, let's just do 1024. So actually, no, that'd be in gigs. So let's just do 1 terabyte, keep it simple. I'm going to do thick provisioning because in case of space reclamation, I'm in the ESX environment. I probably want to do, since I'm in ESX, I'm going to do 1 meg block size. In this case, I'm not going to be using the write log, so I'm actually going to go disabled. And that's it. I'm ready to connect to that target and start writing data to it. There are deeper functions that you can talk about. We can do that at a later time, where we could talk about using the write back caching capabilities, enable CHAP or IP address restrictions. But right now we just did an overview of it to show how quick and easy to make the Z pools, adding capacity to the Z pool, and creating the target within literally in a minute and a half, 2 minutes. Shares, same thing. You're going to have the same kind of functionality where you're going to add a data set now. And so here we're going to call it data set 00. Leave my 1 block size. I am going to use, let's say, the write cache on there, but I'm not going to need the write log. We're not going to need any write log. Again, we don't have one, so let's just go turn that off. And I'm not going to talk about the quotas. We can go into that another time. And of course, once you have your data set, then I'm able to create the share name. And here we'll just create a share name. For simplicity reasons, we'll just call it data. I've already, you want to be able to, once you create share, I want to make sure that which protocol I'm using. So for example, right now, Rick is connected to his ESX with NFS. And of course, you have the functionalities of all squash, no root squash, but usually the default is more than what you need for just getting up the system and connect to it through an ESX or some of your Linux OSs. After that, it's just going through the user group access, which there is none for the NFS summary, and you're done and you're ready to connect to that share via NFS. The last piece is what happens if node A fails, logically or physically. What we've added is what's called a virtual IP address. And that way, if node A fails, node B can take over. How? Very simple. What we've done is we want to be able to create a virtual IP address. And that virtual IP address is established between both systems. So they're kind of married through the NICs that we're going to select. So let's just do this right now. So we're going to call this VIP-1. I'm going to give it a class C. And then we're going to select the interfaces. So this is where Rick at Neurothink, you're using the 100 gig E, correct?
Yes, sir.
So let's say my ETH, this is where you, for everybody's reasons, you want to keep the NIC. So you don't want to mix a 10 with a 10 gig E with a 40 gig E. You want to make sure that ETH1 is the same port speed as the ETH1 on the other side, or if they're mixed, that's okay. Just make sure that 10 gig E is talking to 10 gig E. So here I did it by IP address. So I know 2.02 is a 10 gig E and 2.221 is a 10 gig E, and I'm going to hit apply. And it's going to create a virtual IP address that my clients and hosts are going to connect to that 10.10.10.10. That means if node A were to fail over, or fail from a power issue, node B would take over, but the clients never lose the data access to be written or read via that virtual IP address of 10.10.10.10. And if I move it over, and I move this node over to node B, I'm basically shoving the pool resources, which is owned by node A, and passing it over to node B. Now node B has the ownership. The pool has been exported and over to node B. Node B is taken over, and the virtual IP address of 10.10.10.10 is still live, and your hosts and clients can write now to, or continue to write, as if nothing ever happened. And that is the simplicity of it. I think that wraps it up from my point of view. I mean, there are some cool things that I can continue to go on and on and on about the Jovian DSS. We are adding a lot of fun features to this. This year is going to be a great year. We add the features, they come with the product, so you don't pay additional costs for it. And any questions, Federico and Rick? Because I'm about ready to pass it over to Rick's side, because I can talk all day about the product. I need to shut up.
I don't have any question on my side.
I'm good.
Okay. Well, Rick, I'd like to see your system, how you're using it, and how you're using it for your benefits and performance, and any questions you have for me. And plus, I probably have some questions for you on how you did your setup. Overall, this is how simple it gets. So with that, if you don't mind getting staged and ready so we can take over and take a look at your screen.
All right, everyone, this is our system internal to Neurothink. And to kind of go over as briefly and concisely as possible, these are our connections in the system. It's not by the book, but it's the way we had to set it up for our connectivity. We have one of the 100 gig Mellanox ports. That's one of our physical paths. And then we have a 1 gig physical path. And then we're talking on 3 different subnets, a 172, a 192.168.110, and then a private subnet for the 100 gig link. And that'll pass into what Todd was talking about with.
So let me interrupt you here, Rick. This is good. This is interesting. You didn't do the bond. You don't have to. I mean, with one of the latest releases. So you went with the 100.2.25 without the bond.
Yeah.
Correct?
So yes, sir. So we have a private subnet for the as required for the NIC interface. We added a VLAN to that same interface so we could have a ping, one of the pings, and I'll go over that breakdown. And then we have our gig interface that's just acting as management. As you can see, the 172.30 subnet is how we're logged in. And then if we go to the failover settings, it'll start to make a little more sense. Here are the IPs for the management subnet. Those are going over the gig links. And then we have our rings, which are the 2 different subnets on the 2 different physical subnets. So if we lose one link or the other, there's still communication to the other side of the cluster. And then the ping nodes on those 2 various subnets. So this is our physical gateway out of our network. That's on the same management interface. As you can see, it's a 172.172.30.102.1. And then I added that VLAN to the 100 gig link so we could have another router interface, which is a fully redundant VRRP interface on our 2 different switches. So if either switch fails, this .1 will still always respond. So that way we have physical and logical redundancy, so we don't have any kind of split brain scenarios or anything of that nature.
That's interesting. On your VLAN, can you go to your system settings and network? Because that's interesting. I'm gonna look at that VLAN. So you created out of that 100 gig E, correct?
Yeah. So there's a native VLAN on the interface. That's this subnet, the private subnet, And then I had to, in order to have another pingable address, I added this .110 VLAN with basically a VLAN interface, and then I gave it that IP so it can basically have another way to ping out and still maintain 2 ping rings, 2 physical paths to, again, avoid the split brain scenario should one fail.
Right. No, that's slick. I mean, I see a lot of different setups, and that's slick. Now, you added the VLAN, but you're still on a switch VLAN too, correct? To be part of that.
So there's a native VLAN that is untagged. That is the physical interface. So that way we don't complicate the communication between the nodes. And then this VLAN is an added tagged VLAN only for the ping ring. Again, just to avoid, the split brain scenario.
No, slick. Now, real quick, you could add another ring node if you wanted to, but if you've got it locked down like that, like you could use E3, which is I guess a 1 gig E connection, as an additional ring node down the road. But other than that, it's pretty good, pretty locked down.
Yeah, we have it separated only because the 1 gig interface is on a physically different switch, and the 100 gig interface, again, is on a physically different switch. So we have the management switch, and then we have the pair of layer 3 switches. So these 2 links not only are separate, but they're separate to the types of switches they go to. So it's, again, another layer of separation should anything physically fail.
Right, bulletproofing. Go ahead. Good setup.
So here are the storage nodes, the storage pools. We have 2 NVMe pools, each of them at around 84 terabytes. And then our SAS pool, which is a JBOD hanging off the main cluster, that's at 160 terabytes. And basically what I planned on doing is basically just to show you, we're going to do a failover, a live failover, as you can see, so you know what the IPs are. There's no sleight of hand here. I'm not a magician. You can see.
Wait a minute. Stop. So Federico, are you getting this? So he's going to do a live failover on production. Neurothink's going to do a live failover on production.
Yeah, we have on the SAS pool, which I will do a failover on the SAS pool. We have VMs running on the SAS pool.
I believe this is a lot of trust that Rick is putting on our hardware and OpenE software. That's the only thing I can say.
So,
thank you.
So we have a 98.10 as the primary, the first VIP, 98.11, and then our SAS is 98.12. And what I'm going to do is, again, because of the way Jovian is set up, I needed something that was on the subnet in order to ping it. So these are actually my 2 production switches right here. These are these Mellanox SN2000 series layer 3 switches. And I'll basically get that going. I'll basically, just for the heck of it, I got 2 switches. I can ping 2 different things. I'll get 2 different things going as I do the failovers. I'll ping 1 VIP on one and a different VIP on the other, and switch as necessary as we go through the failovers. So let me get
this part of the video is probably the most interesting part of the video out of all of it, and this is where you shine right here. This is going to be interesting.
So you guys can still see my screen, right?
Yeah.
Okay.
I'm good with. I see the pings. Now those are the virtual IP addresses, right?
These are the VIPs. These are not any direct IPs. Like I said, if you track the IPs over here, you can see 98.10 and 98.10, 98.11 and 98.11. So this is my primary pool, my primary node, as you can see up here. I'm going to go to node 2, and I'm just going to grab that first node. So take note in the latency times. We're in the sub, 100th of a millisecond. So take note of the time as I do the failover. Still talking. Again, it's just waiting for the move to complete. You should see the pings are still moving. So the second node has grabbed the ping, and you can see no appreciable difference in the latency on, again, 98.10, which is, I can click it, which is this guy. So you saw no appreciable difference in latency. So I will stop that ping and start this up on the SAS node again, just to have different, because this the entire time was pinging another node, and I didn't notice any appreciable difference in
Wow.
in latency. Let me do the second node. Clear that up. So the second node is 98.11 again. That's this guy. That's the NVMe pool 2. He is still on node 1, and we're going to go, and node 2 has already grabbed the first pool. So back to this one, that is 98.11. I will go ahead and go over to node 2 and grab him. And again, just keep an eye on the latency over here. On this second window here, you can see 98.11.
I didn't know you were going to show this, Rick. This is kind of cool.
So as he's moving the node, again, we're in the, see that jumped a little bit. You got a 2.10. Again, we're talking about dot 2.10, a fraction of a millisecond. And now we're back to, it's in the neighborhood, but it never dropped, it never spiked. We never, it's all in line as
Right.
as it grabbed the volume.
And those are all NFS data sets
Yes,
that you have on there.
Yes, sir. That was a requirement of the VMware software-defined data center standard. VCF requires NFS. iSCSI is not even an option. So this is all
really?
NFS. There's a single IP. There's no initiator IP. It's one IP for the whole environment.
Right? But is that for your particular setup, or is that what they're pretty much?
That's a VCF requirement with VMware. They require NFS. They don't. VMware supports iSCSI at a standalone host data store level, but for VCF and the software-defined data center concept, where it's all pseudo automated and pseudo, they're trying to minimize. It's all the deployments mostly automated. That particular product requires NFS.
Wow, Federico, I mean, that's the quality of your system in our software, and that's why we certify systems, to vet it out. I mean, we always do catch some issues, but I'm going to tell you, I work with a lot of systems all over the world, and with a 75,000 installation base, you kind of see it a little bit. But with zero ping loss, I typically see 3 to 6 ping loss on some systems, depending on how they are and how it's set up and designed.
And again, but in all transparency, our NVMe pools are not in production yet. Our SAS pool is in production. It does have VMs on it, so that was the other one I wanted to keep going. I'll go ahead and get that one started. Like I said, this because we're still in proof of concept, so our environment isn't completely built out yet. But this is the SAS pool, as you can see. Again, no sleight of hand. The SAS pool 1, 98.12. You can see 98.12. And I'll go ahead and grab this guy. And again, these have, in fact, let me see if I can ping an address of a machine as we're doing that as well. If you bear with me for just one moment.
Yep.
I can bring up a machine. Hold on.
But Federico, even with access to the pool or not access to the pool, just moving that over, I've seen 2 to 3, up to 6 pings, depending upon the system. And I haven't seen something of this well performed where the zero ping loss.
So what I've just set up now is 98.12 is the SAS pool. And 100.178 is a live Ubuntu machine in the environment, as you can see right here. Again, no sleight of hand. This is a machine on our workload cluster, which is backed by Jovian, and that's the IP address right there. 100.178, 100.178.
Got it.
Let me go ahead and grab the storage. Just again, watch the millisecond.
Right.
We're in the tenths of a millisecond here, and here we're in the about 40 tenths of a millisecond.
Right.
Grab that guy and move him.
Yeah, I see what you mean.
So it went. Oh, that one went. That one went a little faster. Okay, so this now says it's moved to node 2.
Right.
Let me refresh this page.
I know actually our design is good, but it's always nice to see proof from customer that actually our design can handle what we say it can handle. Thank you very much.
So
yeah, I mean, like I said, I've seen this where customers with and without, being accessed. And I'm typically used to seeing 2 to up to 6 ping loss. In fact, your competitors, the top end competitors, they do some weird caching on the end, but even so, that's really good.
So as you saw now, the first node, which is where they were all originally, they're all now moved to the second node. And as you can see, this was live the whole time with no appreciable, there were no ping drops and no appreciable huge spikes in latency.
Correct. Sweet. That's sweet. That's impressive. Well, that just stole the show right there. So wow. I mean, Neurothink's customers are going to be happy once you get this in 100%. Now, are you going to be growing and expanding this, or what you're looking at other solutions with this type of setup? And why? You can put an active solution where your one node has one set of pools and the other node can take ownership of the other set of pools. So you're kind of load balancing your resources, or is that you're just happy where you're at right now?
We have no specific preference on which pools reside on which cluster. We're going to test it both ways, where we're going to test it with all the pools on one cluster and a part of the pools, maybe 2, and then 1 on the other, just for the sake of it. But in the end, what we really need to know is, can everything run at full speed on one cluster, on one node? Because in the end, that could be a real life scenario where we lose a node, everything fails over, and we need to make sure there's no interruptions in service. So we'll test it both ways, but for the majority of the time, it's probably going to run on one node, and one node will most likely act as
right. Right. No, that makes sense, and I understand that kind of thinking. And I talk to a lot of engineers, and they all cook their dinner differently in the kitchen, and you're right. At the end of the day, that's exactly where it's going to be. So you need to know that load's there. That's it from my side. I don't have any more questions, so probably what we want to do is stick around for a few more minutes for some of our customers to ask questions about our products, our usage, and any other questions they may have, so we can help them out.
Hello, this is Joe Kimpler, your moderator. We're going to be opening up all the mics so that people can ask questions. The first question that came in, this came into the private chat. I think it's for Federico. Can you tell me more about the functionality of the IPMI interface?
Okay. So IPMI interface is for management. So call it most publicly as light out management. As long as you have power connected to the server, you can access it. Functionality, mainly are hardware management from the power on, power off, restarts, controlling whatever is going on the system. You can have a virtual keyboard, mouse, and video remotely, and also control all the thermal inside the machine. So you can access via a web interface, and or for people that are a little more savvy, they can access via command line.
All right, thank you, Federico. Everyone's mic should be open now, but here's another question that came in. Looks like this one's for OpenE. Can you have more than one Zpool in a cluster configuration?
This is Todd from OpenE. Yes, you can. We have by default up to 3 to 4 Zpools, but if there is a need to extend that to up to 8, we ask that you contact us and we can provide you a small update. And the reason for that is that when you start adding a lot of Zpools, especially when you're in the petabyte ranges, things get a little heavy. So that's why we kind of lock it down to like 4 at default. There is some needs that you can have more Zpools, but we prefer to give that small update out individually instead of publicly, so we understand your system. We just don't want you to have a bunch of SATA drives and expect the world out of that, because you're just not going to get that kind of performance with that low-end type of devices.
Okay, anyone can speak up, but we do have another couple questions that came in the private chat. I'll go ahead and keep asking these questions unless someone in the audience just go ahead and talk into your mic. This one looks like it's for Federico. Can you provide additional details on the OCP slot?
OCP is just a PCIe form factor. It's based pretty much on the same technology, PCIe. But yeah, it's a little more compact, so we can squeeze in. We've been using it for quite some times, and to squeeze in as a little more cards availability. As in the market, you can find major player in this providing this kind of form factor, like from Mellanox, Intel, and so on. So yeah, it's another way for squeezing in a little space, more connectivity.
Joe, I can expand on the OCP a little bit. This is Rick Rodriguez from Neurothink. OCP was a platform decision made from big players like Facebook and Google and the like, that they wanted to, like Federico's point, they wanted to make a more manageable interface and form factor for NICs. And like he said, it was predominantly for NICs, and it's just to give platform packagers like Supermicro, AIC, and the like to give them more flexibility in deploying a variety of NIC solutions.
Thank you, Rick. Hey, as long as I got you on the line, this one came in. I'm not sure it was a planted question or not, but it says, what does machine learning and radically accessible mean?
So that is almost a direct pull from the brain of my CEO, Brian Rogers. He wants everyone to be able to access machine learning. You know, not just data scientists, not just, you know, data analysts, not just, you know, statisticians. He wants to be able to create a platform where people can come in that aren't necessarily well versed in the subject matter and get guided through importation of their data, get guided through using public data models in order to get put machine learning to use either on their data or public data models in order to get the results they need. However, at the same time, if you are well versed in the subject, we'll still have that flexibility for you. You'll be able to gain access to the command line, and you'll be able to, you know, really get knee deep in it if that's how you want to use the platform. We'll have the flexibility to go both ways.
Thanks a lot. This one looks like it came in. You know, you guys don't have to send it through the chat. You can ask questions live. But is this solution ready to support hyper-converged infrastructure? And does it work with VMware and Hyper-V? Sounds like that's for Todd.
Yeah, this is Todd. So yes, it is. It has been. We are certified with VMware, always have been for a very long time, since 2007, I believe, on all our products. Yes, but currently it's with Hyper-V and VMware, because those are the most commonly standard in the industry that we see. I would say about now almost 90% of our customers are using those platforms. So yes, we're seeing a lot of hyper-converged environments when we see cases come in or when it's being sold. Alrighty. By the way, we also have in our release notes a small documentation on how to install the Jovian as a virtual machine. Very simple. some notations there for engineers to install our trial versions, which we give for 60 days. So you guys have a lot of time to test and put it through its trials and tribulations. And in this way, we like for engineers to download our trial version so they can test it. But in our release notes, we give you the guide on how to set up the virtual machines, the Jovians, DSSs as virtual machines in a Hyper-V or VMware environment.
Alrighty, again, as a reminder, your microphone should be open, but you guys are keeping on typing in the chat box. Yeah, this one looks like it's for Todd too. Is Jovian DSS compatible with the latest Intel drives such as Intel Optane?
Yes, and the reason is that we're very close with Intel. We've been working with Intel for since 2006, and Intel works with our engineers from the official products that are released out on Intel site and Intel distribution and resellers, all the way down to the secret programs. So the answer is yes.
All right, thank you. Again, everyone's mic is open. I'll give it a couple seconds here for anyone to go ahead and chat in your mic. You can keep typing in the chat box, in the question box if you want, but you can also ask live. I'll give you guys a couple seconds to work up your
By
courage.
the way, while you're giving them time, Joe, there was a question that came up, and I don't know if it went through to everybody. I did send it all about the backup functionality.
Yeah.
The Jovian DSS was a question about, does Jovian DSS come up with a backup functionality? Yes and yes. If you go to the open-e.com, and right there you'll see the tab called Solutions. There you'll see backup solutions, backup and restore. From there we provide detailed information of how the backup functions, and the backup and restore functionality in the Jovian DSS in the GUI comes free with the product. And again, that's a feature that we're seeing being purchased a lot due to offset a lot of the ransomware, malware, and the hacking and that's happening, and also to restore data. You know, you can restore data from a minute ago if you wanted to. So there's retention times that you could set that are really just wonderful for an engineer, whether it be on a block base or a file base. It works for all the protocols.
Thank you, Todd. Give you guys a couple seconds. Your mics are open. But you continue to chat, type in the chat box. This looks like it's for Neurothink. Why Jovian and AIC?
So at the beginning, this was these nodes and being preloaded with Jovian were acquired before I came on board. But just being in all transparency, but I can tell you it was mostly a byproduct of the fact that when Neurothink started, you know, being a startup, we had to get something that was affordable, quickly deployable, and something reliable. And software-defined storage is kind of right there in that niche. You can go out and spend a ton of money and get a huge team to support you in, buying a SAN array from vendor XYZ. Pick a huge SAN vendor, and then if you pay enough money, they'll bring the array in and practically do it all for you. But being that kind of being the small startup space, you want to get it done quickly, affordably, and efficiently. And the AIC and Jovian units really fit that model. We got it deployed within a few days, and maybe a few questions to support. We had everything stood up, and we're really happy with the latency so far. I'm just really looking forward to getting some huge data models in there and seeing what it's really capable of.
Thank you. I'll give you a couple more seconds to anyone for the open mic.
Hey, Joe, this is David. I got one.
Hello, David. Go ahead.
Yeah. Hey, Todd. My name is David from AIC. So I got a question for you. In the conference, I have some partners, or they are from the media, sports, and the entertainment business. So I want to ask them, ask you this question for them. So if you can share some selling point or advantage or any optimization on using a Jovian handling the media files.
Yes, so we are in the M&E market, that's media and entertainment,
Right.
very prevalently. And we're in Legendary Films, we're in a lot of the, you know, from all the way Tyler Perry Studios. I mean, we're everywhere in that media market, from Europe, Israel, you name it. What we've seen in the media market for performance, obviously discs, and obviously high performance NICs, and typically in an SMB and also NFS, because you're dealing with a lot of Mac environments at that point for editing, for rendering, especially when you get into the 8K environment. What we've seen is that when you're dealing with at the file level, you're going to be more relying, depending upon how many files we're dealing with, and we do have special settings for that, especially with Fruit and a few other additions. You can set in what's called the data store. Now, I don't see too many at the block level other than Fiber Channel. I mean, HBO, a few others do that with Fiber Channel, and that's because of the frame is larger, so the payload is larger. Yes. Now, back to the SMB and NFS, I am seeing a lot of NFS being done as well, because the AFP that's native into the Mac world is diluting, and people are finding out they're defaulting back to SMB versus or NFS versus the AFP, Apple Talk Filing Protocol. Now, there are settings that you can do with our caching capabilities to improve the performance is with our read cache. And of course, you know, we have a 2-tier caching system, which is RAM. We're going to use RAM first, so we love RAM. Jovian, really all types of the ZFS zettabyte file systems love RAM first for the read cache, and then secondary is the L2 ARC, where you're using SSD or NVMe. So you get the performance from that, because then you're not requesting the information coming from the disk groups that are compiled together to make the Zpool. There's a lot that can be addressed, especially for jumbo frame. You can set in the system for the NICs. There are some kernel adjustments that are fine-tuned. Very rarely have I gone that deep with a customer, except for one where they were dealing with a lot of millions and millions of tiny files, and we were just trying to squeeze every inch out of it. I mean, you're talking, they had a certain database file read for camera views. Oh my God, they had like, they're using drones for like 100 drones. It was a crazy scene. And of course, they had to compile it in such that it created just a ton of shots at that one time. The only reason I'm bringing this, and I'll end up quieting up after this, is that they were getting around 500 reads per minute. We got them up to 50,000 reads. And just by tuning and tweaking on different, now mind you, that was very small files, but still, again, the requirement was to go beyond their 500, and we took it up to like 49,800, something like that. So it came up to about 50,000. So yeah, there's a lot of stuff that is there in the Jovian that, you know, take a few minutes to understand different types of the media, how they're handling it, what they're doing, rendering, are they reading, things of that nature that we can help tune it. But typically out of the box, I would say 50%, just as long as the hardware is golden for their needs, and you have the NIC and the CPU and the RAM and the drives, 50% just come straight out of the box ready to go, and they're fine. The others are the top end, where they really got to squeeze a lot, and that's where we do have some settings, but I just need to know, I mean, how many files, how large are the files? So it gets to be a big topic when you talk about it. We should have a separate webinar just based on media. Of course, you could do webinars till God, you know, end. There is no end. I mean, you could do different types of webinars on disk performance, different types of how to utilize RAM. So the list is endless. But yeah, we do it.
Thank you, Todd. Are there any other live questions? Okay, everyone. Well, if there's additional questions, you can go to any of our websites, www.aicipc.com, or you can always send me an email at jkimpler, K-I-M-P-L-E-R, at aicipc.com. All right, well, we'd like to thank you very much for attending the webinar. We enjoyed the conversations. Again, if you have any questions, please go to our websites. And everyone, make it a great day. Take care.
Well, thank you very much for everybody. Thank you. Bye-bye.
Adios.
Adios.
Bye-bye.